right, so yesterday we talked about wavelength and frequency, and we learned that when a wave is very, very large, many times its frequency is going to be much, much smaller. Okay, we said the wavelength is how big the wave is. The frequency is how many waves pass by a certain point every second. Okay, and so we'd said, again, basically what you can see here, that if a wave is very big, if it has a big wavelength, and again, it's always traveling at the speed of light, it's going to have less waves pass by per second, so it's going to have a smaller frequency. Now, mathematically, we can do this, okay? And so there's an equation that relates, remember yesterday, or the previous lesson video, this is the wavelength right here, so that backwards h, remember, which is lambda, that's the wavelength, and that v looking thing, which is actually mu, is the frequency, okay? And so we can see here that the wavelength multiplied by the frequency is equal to this letter C. And the letter C is what we talked about already yesterday. It is equal to the speed of light. There's that famous Einstein equation, E equals mc squared. C in that equation is also the speed of light. And the speed of light is always 3.00 times 10 to the 8th. Remember, that is 300 million meters per second. Okay? And that's pretty darn fast. So, which means that if I give you the wavelength, you can find the frequency. And if I give you the frequency, you can also find the wavelength. So let's look at an example of this. Example number 1 says calculate the frequency of a wave. So remember, frequency is this one right here. So we're trying to find that V looking thing. Calculate the frequency of a wave that has a wavelength of 2,500 meters. So in this problem, I'm giving you the wavelength and I'm asking you to find the frequency. So this is going to require some of your algebra skills. So if we start with speed of light equals wavelength times frequency, and we're asked to find the frequency, that means we have to get V by itself. And to do that, using algebra, what do? We divide by the wavelength. So we're going to divide both sides by wavelength, and the wavelength cancels on this side, and we're left with the speed of light over the wavelength. And so notice that's what we have here. We have the frequency is equal to the speed of light over the wavelength. And now what do? We just put the numbers into the equation. So we take 3.00 times 10 to the 8th. We divide it by 2,500. And again, I think I showed this to you already, but you really need to have a calculator for this class. Okay? And so when I put this into my calculator, I'm going to put this in. When I put scientific notation into my calculator, I'm going to type in 3.00. And then on a calculator that you have, on mine, let's see, where is it? It's actually right above the 7 right here. There's a double capital E right there. So yours will either have a button that looks like this. It might have a button that says EXP. Or it might even have one that says times 10 to the Y or times 10 to the N. It's one of those 3 buttons. So on my calculator, I'm going to type in 3.00. I'm not sure how well you can see that. 3.00, and then I'm going to hit that double E. And on my calculator, it's that one. And then I'm just going to type in the number 8. I don't hit times. I don't put in the number 10. I don't even raise it to a power. This button does all of that for me. Okay, so on my screen right now, again, I'm not sure how well you can see that, but it says 3.00 capital E 8, not lowercase e. Don't use the lowercase e. That's different. Okay, and then I'm going to divide by 2,500. Okay, and then you can see on my calculator, it does say 1.2 times 10 to the 5th. On your calculator, it might say 1,200,000. That is the same thing as 1.2 times 10 to the 5th. If you haven't used scientific notation before, that's just an easy way to go for, instead of putting all those zeros there, 1.2 times 10 to the 5th is the same thing. Now, what does that mean? It means that 120,000 waves would pass by that point every second. Okay? And if we go back to that previous page with the electromagnetic spectrum on it, here we can see that 2,500 meters, well, here's 1,000 meters, here's 10 kilometers, so it would be somewhere in this range right here. You'd be in the radio wave range with that frequency. Okay, number 2. Okay. Now, something to consider here as well is what do I need to put in my answer? Okay. And the answer is, notice here that you've got 2,500. It's got some zeros at the end, but the 2 and the 5 are the ones that matter. So that means that if your number has 2 digits that are what we call significant, then your answer should also have 2 that are significant. And we'll talk about that in more detail, but that's not a big deal. Okay, let's look at example 2 here. It says, calculate the wavelength of violet light that has a frequency of 7.5 times 10 to the 14th seconds to the minus 1. So in this example, I give you the frequency, but I'm asking you for the wavelength. So again, let's start with our original equation. Speed of light equals wavelength times frequency. And they're asking us for the wavelength. So to get wavelength, I'm going to divide by the frequency on both sides. So frequency cancels over here, and the wavelength is equal to, as you can see here, the speed of light over the frequency. Okay, and so now again, I just go to my calculator, or I put the numbers into the equation first. Here's the speed of light on the top. I put the frequency on the bottom, and then I divide. So again, I'm going to go to my calculator, and here's where you kind of have to be careful. So I'm going to go 3.00 times 10 to the 8. So notice on my screen it says 3.00 E8, and then I'm going to divide by, and now here's where you want to be careful. It's a good idea to put that next number in parentheses just in case your calculator does it wrong. So notice I put 3.00 times 10 to the 8th divided by, and then a parentheses, and now I'm going to go 7.5 to the 14th, and then I close those parentheses, and now I hit equals. Okay, and then on my screen, again, I can see it does say 4.0 times 10 to the minus 7th. Again, on your screen, it might say 0.0000004. Again, much easier just to put it into scientific notation. If you need a quick review on scientific notation, guess what? There's lots of videos on the internet to do that. Okay, so let's do a couple more examples here. It says the gamma rays released in the Chernobyl disaster in 1986 had a frequency of 6.35 times 10 to the 20th seconds to the minus 1. What was the wavelength in meters of those waves? So we did a problem just like this already. They want the wavelength. So again, start with, and again, write these examples down. The speed of light is equal to the wavelength times the frequency. So to find wavelength, we're going to divide both sides by the frequency. So the wavelength is going to equal the speed of light, 3 times 10 to the 8th meters per second, over the frequency, which is 6.35 times 10 to the 20th seconds to the minus 1. And now I just put those numbers into my calculator. 3.00 times 10 to the 8th divided by 6.35 times 10 to the 20th. And sometimes, guys, I'm not perfect. Sometimes I'm going to make mistakes and type these in wrong. Sometimes I'll do it on purpose just to see if you're paying attention. But sometimes I'm just old and I screw up. So 4.72, again, notice 3 numbers here. So I'm using 3 numbers in my answer. So 4.72 times 10 to the 13th meters is my final answer. Okay? Except I did that wrong. I know that I did that wrong. And the biggest problem is that I just couldn't see it. I believe it's 4.72 times 10 to the negative 13th. How about that? Good. See, I already told you. I mess up sometimes, and I literally just couldn't see it on my calculator screen. Yep, 4.72 times 10 to the negative 13th. Okay? The waves that travel between cell phones and their towers have a wavelength of 0.352 meters. What is the frequency of those waves? So again, start with this equation. Speed of light equals wavelength times frequency. To find frequency, we're going to divide by wavelength. Is it kind of the same thing every time? It sure is, yep. So the frequency is the speed of light, 3 times 10 to the 8th, divided by the wavelength, 0.352 meters. So now I'm, again, 3 times 10 to the 8th. Divide that by 0.352, and I get 8.52 times 10 to the 8th, and that is seconds to the minus 1 left over. Anytime it's frequency, the units are always going to be seconds to the minus 1. Okay, a couple more examples here, and then we will be done with this, and then you can practice. Okay, X-rays have a wavelength of 1.00 nm, and nm stands for nanometer. And a nanometer, or basically a meter, has 1 times 10 to the 9th. That's a billion nanometers. So nanometers are really, really tiny. Okay, and they want to know what is the frequency of an X-ray. So I give you a hint here. It says you must convert nanometers to meters before converting to frequency. So the first thing we have to do is this nanometer thing, that's not going to work. Okay, we have to have it in meters. So what we're going to do is, again, this is some basic math here. We're going to do a conversion from nanometers to meters. Here's my conversion right here. So that means I'm going to take nanometers, which are on the top, and I'm going to put them on the bottom. So I'm going to put 1 times 10 to the 9th nanometers on the bottom, and whatever it's equal to, 1 meter goes on the top. And the reason we put nanometers on the bottom is because of this right here. Notice that if nanometers are on the top and on the bottom, they cancel. Okay, so now I go to my calculator. 1 divided by 1 times 10 to the 9th equals 1 times 10 to the negative 9th meters. Okay, now that is my wavelength. Now it just turns into one of the other problems. Okay, how do I get wavelength? Wavelength equals, how do I get frequency? Frequency is equal to the speed of light over the wavelength. So you put the speed of light here, put the wavelength here, divide them. I'll tell you right now, it should be a really, really big number. Okay, I don't want to tell you what the answer is. I want you to figure it out this time. But I'll tell you right now, it's going to be times 10 to a really big number up here. Probably bigger than 10, less than 20. I'll give you that much, okay? But if you're not putting your calculator the right way, you're not going to get the right exponent up here, okay? That number is really important up here. So it should be a fairly large number. And if you're having issues with that, then talk to me. Hey, that example 5 you did, I never got an exponent between 10 and 20. I don't know what I did wrong. That's where we can sit down and talk about that together. Okay, and then example 6, kind of like example 5, just backwards. So I'm giving you the frequency, and they want the wavelength, but they want the wavelength in nanometers. So what's the first thing that you need to do? Again, I'll set this up for you, but then you do it. Okay, is to get wavelength. That's equal to the speed of light over the frequency. So again, speed of light doesn't change. The frequency is that number right there. And your answer is going to be something meters. Okay? Once you divide those. And again, I will in this case, the frequency, or the wavelength is going to be a fairly small number. It's going to be times 10 to some power. And that number is going to be a negative number, and probably a negative between -4 and -10. I'll tell you that much. Okay, so you figure that one out. See if you can get it. Should be between -4 and -10. Okay, once you get that, now we need to convert those meters to nanometers. So similar to what we did here, but now meters are on the top. So I need to put 1 meter on the bottom, and then 1 times 10 to the 9th nanometers, because that's the conversion I gave you up here to get nanometers, and then your answer will be in nanometers. Okay, and then once you do that, it should be the overall answer should be somewhere in the hundreds, I believe, if I remember correctly off the top of my head. Is your answer should be like, 700 and something. Okay, not 7.0 times 10 to the something or to the negative something. It should be, again, a number that's bigger than 100 but less than 1,000. Okay, so try to get that, see if you can get that correct answer, and then we'll do some practice problems on